Hello everyone. This video is on the Knewton Alta assignment for section 4.5 part 1 called Slope-Intercept form. So in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same and the structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. On the assignment page should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives. Looks like there are 4 objectives for this assignment. Under the current objective, there should be a question related to that objective. And at the bottom of each question, you should see a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. This is for instructors only. But you will have a more instruction button. So if you're struggling with a topic or a question, click on this. You'll be taken to a page with some reading or some videos to study, and then you'll be given questions on that related to that instruction, and completing those questions will help you progress through the assignment. Alright, so the first objective I'm looking at is identify the slope and y-intercept from an equation of a line and relate a graph to the equation. Alright, so in this first question we're asked to identify the slope and y-intercept of the line 3x plus 2y equals 14. Alright, so there are a couple ways you can do this. I'll do the long way first and then the faster way second, as usual, but it really depends on what you prefer. So the equation we're given here is 3x plus 2y equals 14. Now you may recall from a previous video, a previous section, that this is a linear equation in 2 variables that's in standard form. Remember, the standard form for a linear equation looked like this. You had some number a times x plus some number b times y equals some number c, right? And that's exactly what this looks like. Ax plus by equals c, right? 3x plus 2y equals 14. We'll get to another form, right, the slope-intercept form, in a minute. Now they're asking me to find the slope and y-intercept of this line. Now the y-intercept is simple. Right, you've found this in previous videos. There was a previous section on intercepts. Remember, for the y-intercept, you let x be 0. Right, substitute 0 for x, so that's 3 times 0 plus 2y equals 14. And I'm hoping that you can see y has to be 7, right? Because 3 times 0 is 0, and then you would just divide by 2 to get y alone. Right, so the y-intercept is the point 0, 7. Alright, then they ask us to find the slope. Now remember, slope is, rise over run. There was that slope formula we saw in section 4.4. It was the change in y coordinates of 2 points divided by the change in x coordinates for 2 points. But remember, for slope, to use this slope formula to calculate the slope, I need 2 points on the line. Well, I already have one of them. Right, I have the y-intercept, 0, 7. So I could just find another point. Right. Now another point I see on this line, and you can verify this yourself, but I just kind of see it. If you remember, if you just plug in, you can plug in a value for x and solve for y, or plug in a value for y and solve for x. If I'm seeing up there, if I plug in 1 for y, this would be 2 times 1 is 2. Then I subtract 2, get 12 over here, and then divide by 3. 12 divided by 3 is 4. There's another point. 4, 1 is on this graph as well, if x was 4 and y was 1. And then I can use the point 0, 7, and I can use the point 4, 1, and find the slope, right, which was usually represented by this lowercase m. Take, say 7 minus 1 for the rise, right, the change in the y-coordinates. And since I did 7 minus 1, I have to take the change in x in the exact same order, 0 minus 4 in the denominator. And this is positive 6 in the numerator, negative 4 in the denominator. This would be negative, and then 6/4 reduces to 3/2. Right? And there's the slope. Here's the y-intercept, right? So those are correct. Those should be correct. I found the slope. I found the y-intercept. We can make a graph of this pretty easily as well. All right, let me plot a graph. And now we weren't asked to make a graph. I'm just doing this for your own benefit. All right, so x, y. We have 0, 7. And if you have graph paper, that might be a little nicer. But here's 0, 7. And the slope was negative 3/2. So if I go down 3 from 7 to 4, and then right 2, here's another point that's on the graph, 2, 4. Right, 2, 4 would also be on this, and you can check it out. Right, so we got 0, 7, got 2, 4, and let's test that out. If x were 2, you'd have 6 in the first term, 3 times 2, and then y is 4. 2 times 4 is 8. 6 plus 8 is 14. That works. And I can keep using the slope to find other points if I want. Right, if I go down 3, that'd be from 4 to 1, and then right 2 again from 2 to 4, there's the point 4, 1 that I said was on the graph. Right? We already said that 4, 1 was on the graph. And I could keep doing this all day long, but you only need 2 points, right? You only need 2 points to be able to draw a graph of a line, right? And the line should be looking like this, right? Going through all these points. There's our line, and it has a negative slope, right? So it should be going down to the right. All right, but they didn't ask us to do that. They just wanted the y-intercept. Right? The y-intercept is 0 for the x always for the y-intercept, comma 7. The slope negative 3/2. Right? Now that was the long way of doing it. I'd call that the long way. Right. The short way is to put the equation in what's called slope-intercept form. The title of this assignment, the title of this section. And slope-intercept form looks like this. Y equals m times x plus b. And people are very often familiar with this form, where m, of course, represents the slope, and 0, comma b is the y-intercept. So basically the b here that's being added is the y-coordinate of the y-intercept, or sometimes they'll just call it the y-intercept, and this is key. Right? This is the important part of this assignment here. Now to put an equation in slope-intercept form, all you have to do is solve for y and simplify. See how it's y alone on one side equals and then an expression without y on the other? So you just need to solve for y and then simplify the other side. Make sure there's no parentheses and simplify any fractions and whatnot. Write it as 2 terms. Once you've done this, then the coefficient of the x, the number attached to the x, will be the slope, and then the constant term, the number being added after the x term, will tell you what the y-intercept is. Alright, so let's do that. So let's take the equation we were given and let's just solve for y. And, of course, simplify our final answer. And once you do this, the equation will be in slope-intercept form. So if I'm solving for y, this positive 2y term, I'm going to keep that on the left. And I would subtract the 3x. So then I'd have a negative 3x on the right, and you'd still have a positive 14, right? So you have negative 3x plus 14 on the right side. And then finally, to get y alone, I would divide every single term by 2. So on the left side you have y equals, then here negative 3x divided by 2 would be negative 3 halves times x, right? Negative 3x divided by 2, negative 3 halves x, same thing. And then 14 divided by 2 is positive 7. And look at this. Now I'm in slope-intercept form. Right, one more time, I'll just write slope-intercept. This is in that slope-intercept form. And you see the coefficient of x, right? The slope is just the coefficient of x once you've solved for y is negative 3 halves, which is what we said earlier. This is what I have in this circle here. Right? After finding 2 points and using the slope formula, I said the slope was negative 3 halves. Well, we got that right away, right here. And then the constant term, the plus b, is plus 7. So 0, 7 is the y-intercept. Right? And it's obvious, if you replace x with 0, this first term will disappear and you'll be left with y equals 7. Right? So you got 0, 7 for the y-intercept. It's exactly the same stuff I found doing it the long way on the previous page. So yeah, so this is very nice, the slope-intercept form. Right? Just solve for y and simplify the other side, get 2 terms, an x term and a constant term. Once you've done this, you should be able to very quickly identify the slope and y-intercept of a line. All right, then going back to the assignment, we'll check, this should be correct. I found it 2 different ways. Now after you submit your answers, you'll be told whether you're correct or incorrect, and then be given some sort of answer explanation. Please read through the answer explanations, right, just to make sure that you understand why something was right or wrong, and then you hopefully can learn from your mistakes for the future. All right, next. So this is graph a line given its equation using its slope and y-intercept. Now again, you've seen how to graph a line before. You just need 2 points. So, if x were 0, y would have to be negative 3 here. So 0, negative 3 is on the line. And if y were 0, x would have to be 6, right? So 6, 0 is on the line as well, and there's the line, right? You only need 2 points. You don't need to put things in slope-intercept form. But, here's another way I could graph this. All right, so again, using the slope-intercept form, the slope and y-intercept. So here's the equation we were given. It's x minus 2y equals 6. All right. And then let's solve for y. So first I would subtract x. We'd have negative 2y on the left equals negative x, and then you still have the positive 6, right, plus 6 after. And then I divide everything by negative 2. So y would be equal to, now negative 1x divided by negative 2 would be positive 1/2 times x. And then positive 6 divided by negative 2 would be negative 3. And here we have the equation in slope-intercept form. I'll just write slope-int now, where the coefficient of x, this positive 1/2, that's the slope. And then negative 3 is the y coordinate. If x were 0, y would have to be negative 3. The point 0, negative 3 is the y-intercept. And then here's how you graph, right? And you saw this in section 4.4, or 4.5 part 1 even. Or 4.4, right? 4.4. you plot a point. Here's 0, -3. There's the y-intercept. And then you use the slope. Rise over run, 1 over 2. So I go up 1 from -3 to -2, and then right 2 units. So another point on this graph would be 2, -2. Right, this would be another point, and you can check it. If x were 2 and y were -2, you'd have 2 plus 4 is 6. That's true. And you can keep doing this. I mean, go up 1, right 2, and the point 4, -1 would also be on the graph. Right, there's 4, -1. Go up 1, right 2, and then you got that other point I plotted, which was 6, 0. Right, 6, 0 would also be on the graph, and all these points are on the graph of this line. It should look something like that, right, straight line. But that's, remember how you take a point on the line, and then you can use the slope to get to other points on the line, knowing if you know the rise and run. So you can do this, or, again, if you're just asked to graph a line, you really only need to know 2 points. So what I did here was, plotted 2 points, 0, -3, 6, 0. Just make sure, double check that those actually satisfy the equation, and you should be good. Okay. Now you see they use the slope. They have 0, 3 plotted, and then they go up 1, right 2, and there's 2, -2, like I had in my drawing. But again, you keep going up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. Either way, as long as you're on the same direction and the same line, you're still going to land on the line, and it's good. All right, next. All right, so same deal, just graphing, moving some points around. All right, so here, all right, this time I'll just do it with the slope-intercept form. All right, so the equation we're given this time, and again, you don't have to do it this way. You can do it another way. Just find 2 points, plot those 2 points, and you'll have the graph, and draw the line through those 2 points, you'll have the graph. So I have 8/5 times x, or 8x over 5, and that's 8/5 times x, minus 2y equals -8. Then I'm going to solve for y. So first I'd subtract the 8/5 x. So we have -2y equals -8/5 x minus 8. You still got the minus 8 over there. And then I would multiply everything by -1/2, or divide everything by -2. So y would be equal to, now a negative divided by a negative would be positive, and then 8/5 cut in half would be 4/5. That's positive 4/5 times x, and then -8 divided by -2 would be positive 4. All right, and here we go. The equation is now in slope-intercept form. Y equals mx plus b. The slope of this line is positive 4/5, and the y-intercept is 0, 4. And if we're graphing, the point 0, 4, there's 4 on the y-axis. That's where the graph crosses the y-axis. That's the y-intercept. And then I use the slope. Rise 4, run 5. That's positive, positive. So I go up 4 to have an 8 y-coordinate. So I should be doing this in black here. And then right 5. So the point 5, 8. Right, if I go up 4, right 5, the point 5, 8 should also be on this graph. And you can check it out. Replace x with 5 and y with 8. You'd have 8 minus 16 is -8. That's true. All right, and then again, all you need are these 2 points to be able to draw the rest of it. Now you could do more, of course. Just keep going up 5, up 4, right 5, up 4, right 5, or down 4, left 5, down 4, left 5, down 4, left 5, as long as you're on the same line in the same direction. So yeah, so one of these points, the y-intercept should be at 0, 4. and then moving this other point to the 0.58. Just click on them, make sure they're in the right positions, right? 0, 4, and 5, 8 were on my drawing. That's the line for this equation. Great. All right, next. All right, so this is graph lines using a variety of methods. All right, choose the most convenient method to graph this line. Now, remember, equations that are in standard form like this, when the coefficients of x and y are both, factors, they both go into the constant on the other side evenly, it would be very easy to find the x and y-intercept and then graph. I would say do that. Now, if these coefficients didn't go into 12 evenly, say one of them was 5x and the other was like 7y, then I would do the whole slope and y-intercept thing. Right. Obviously, it's not a vertical line or horizontal line. Right. So yeah, so again, just a little tip here. If it's in standard form, ax plus by equals c, and a and b go into c evenly, like this here, it would be a lot easier to just find the x and y-intercepts and graph. Let me show you. Right. So again, this equation here. Now you don't have to do that. Right? They're just saying what would be probably what's considered by most people to be the most convenient. See, if x were 0, this term would disappear, and then you just divide by -2, y would be positive 6. See, that's why it's easy when the coefficients of x and y go into the constant on the other side. And then for the x-intercept, you let y be 0, and if y is 0, this term's gone, and then you just divide by 3, x would be -4. And yeah, finding the x and y-intercepts are very simple. So 0, 6, -4, 0, there's your line. Very rough sketch, of course. But finding the intercepts would be very quick. Now, if you were to solve for y, y would be equal to positive 3/2 x, right? I'd subtract 3x and then divide everything by -2 plus 6. And you have 0, 6, and then you'd go, up 3, right 2, or down 3, left 2, and be on the line again. You could do that too. It's just I feel like the intercepts are easier to find, again, when the coefficients of the variables go into that constant on the other side evenly. Right. Okay. Alright, so back here, identify the slope and y-intercept. So once again, I'm going to take this equation, we're going to solve for y and simplify and put it in slope-intercept form. So we have x plus 2y equals -2. Right, so 2y would be -x minus 2, and then dividing everything by 2, y would be -1/2 times x, and then -1. So the slope is -1/2, and the y-intercept would be 0, -1. And that's all I'm entering. So slope, -1/2, and the y-intercept, x-coordinate 0 always for the y-intercept, y-coordinate -1. And it really should be that quick. Alright. Now this is graph and interpret applications of slope-intercept. Alright, so if you know what you just have to, now you have to pay attention to what the variables in the equations represent. So like Margie here is planning a dinner banquet. The equation C equals 750 plus 42G models the relation between cost in dollars, C, of the banquet and the number of guests, which is represented by G. Interpret the slope of the equation. All right, so let me write this out here, and think about it a little bit. So the equation we're given is C equals 750 plus 42G. All right, so C represents, the cost, right, the cost in dollars of this banquet, and G represents the number of guests at the banquet. Now, if I put this in the way that, remember slope-intercept is y equals m times x plus b. So if I write this in the same order where it's like, C is like the y, right? The cost is like y. And then put this in the variable term and then the constant term order, you have 42g plus 750. And if I were to graph this, this time the horizontal axis, instead of being the x-axis, would be called the g-axis, right, for the number of guests. And then the vertical axis, instead of c, it's, instead of y, it's called c now, right, cost. And I hope you can see now, this is in slope-intercept form. The slope would be 42, and the y-intercept would be 0, 750. All right, so this is, say 750 here. And then a slope of 42 means that if I increase the number of guests by 1, I'd have to increase the cost by 42. So 1,792 would be on the graph, right? And here's the equation, the line for this cost function. Now, of course, I'm not going to keep it going over here because you can't have a negative number of guests. Doesn't make any sense. But the y-intercept means that, if no one came, if there were no guests, it would still cost $750 to hold this banquet. That's probably for the cost of the rental of the building or whatever, the hall, or the cost of the chefs or the catering company, whatever. If no one came, the banquet would still cost $750 to hold. Banquet costs, $750 to hold. Now, the slope being 42. Remember, this is a change in a vertical change over horizontal change. Basically, it means it costs $42 every time a new guest shows up, right? If I increase the number of guests by 1, the cost goes up by 42. So here's one guest, then the cost of the banquet $792. Add another guest. If there were 2 guests, you add 42 to this, that'd be $834. So 834, and so on. But the slope, the way the slope would be interpreted here is, it costs $42 per guest. Right, and that's really what slope is. It's a rate of change. It's a rate of change, so the word per is usually going to be in there, costs per guest or dollars per gallon or whatever. Miles per hour, stuff like that. Those are rates of change, and that's what the slope is. Slope is a rate of change. So back here, looking through these, the slope 42 means that each additional 42 guests cost the cost of the banquet increases by $750. No. This here, the slope of 42 means that for each additional guest, the cost of the banquet increases by $42. Right? $42 per guest. I hope that makes sense based on my graph. Right? A slope is a rate of change. How much the output will change when the input changes by 1. All right. Another one of these, graph and interpret applications of slope. Alright, so here's Patel's weekly salary includes a base pay plus commission on his sales. So the equation S equals 750 plus 0.09C models the relation between his weekly salary, S in dollars, and the amount of his sales, which is C in dollars. So slope again. Now the slope here would be 0.09. 0.09. And remember, what slope means is if I increase C by 1, his weekly salary will go up by 0.09, will go up by 9 cents. So that's this interpretation here. It means that Patel's weekly salary increases by 0.09 of a dollar for each dollar in sale. Every time he sells one more dollar, the salary goes up 9 cents. Very similar to the previous problem with a slope of 42. Right? But that's what slope is. Slope tells you how much one quantity will change if the other quantity is increased by 1. All right, and graph lines using a variety of methods. Once again, here's an equation in standard form. Ax plus by equals c. It would be a lot easier to just find the intercepts and graph. Right, an equation in standard, and that's what I read also in the answer explanation from the earlier problem. They're just saying straight up, if an equation is in standard form, it's probably just easier to graph the intercepts and then graph the line. Alright, then here, identify the slope and y-intercept. So once again, I'll write this equation out. We'll put it in that slope-intercept form and answer their question here. So 4x plus 5y equals negative 30. All right, now I want to put this in slope-intercept form, solve for y. So I subtract 4x first. So 5y equals negative 4x minus 30. And then divide everything by 5. Y would be equal to negative 4/5 times x, and then minus 6. So the slope of this line is negative 4/5, and the y-intercept is 0, negative 6. Right. That's all they want. And of course, you could make a graph by plotting the y-intercept and then going down 4, right 5, and then plot another point and graph it, but we're not asked to do that. So the slope, negative 4/5, and y-intercept 0, negative 6. Great. Alright, so one more of these. Alright, this one I'm just going to talk. You can write it out yourself. First, I would subtract x to give me negative x on the right side, minus 18, and then divide everything by 3. So then the coefficient of x would be negative 1/3, and that'll be the slope, negative 1/3. And then the constant term, negative 18 divided by 3 is negative 6. So the y-intercept would be 0, negative 6. Pretty simple. Alright, so that objective's done. So now again, graph a line. So here we know the point 0, negative 2 is on it, right? This is in slope-intercept form right now. The slope is negative 5/6, and the y-intercept is at 0, negative 2. Right, so 0, negative 2. And then the slope of negative 5/6 means let's go down 5, right 6. So I go to 0, negative 2, go down 5 units, and then right 6 units. And there's the point, 6, negative 7. So 0, negative 2, 6, negative 7. And again, you can check that, make sure that 6, negative 7 actually satisfies the equation, and it will. Put in 6 for x, negative 7 for y. And there's your line. Great, yeah, those should be also pretty simple in my opinion. And then looks like one more of these. Alright, so now the equation is not in slope-intercept form. But again, I can easily put it in slope-intercept form. Now, the y-intercept, when x is 0, y would have to be negative 1. Alright, and then the slope, I'd subtract 3x and then divide by 2. The coefficient would be negative 3 halves, meaning go down 3, right 2. So if I go from the y-intercept here, down 3, right 2, I have the point 2, negative 4. And you can check that 2 for x, negative 4 for y would work here, right? You'd have 6 plus negative 8 is negative 2. That's totally true. And there you go, right? 2 points and then the line through them. Great. Alright, then after this, alright, then once again we're given an equation in standard form, ax plus by equals c, so it would be much easier to just find the intercepts first and then graph it. So alright, y. Why is that not correct? Oh, I see. I didn't read the instructions. Which two of the following are appropriate methods to graph this? Alright, so there's another lesson for you. Don't rush, read the problem. So yes, finding the x and y intercepts and then graphing would work, but also, since it's got an x and a y, it's not going to be a vertical or horizontal line, but you could find the slope and y-intercept and then graph, right? Put it in slope-intercept. Okay. Okay, so I didn't read the problem there. I do apologize. So that's going to back me up a bit. Alright, so this one is choose the most convenient way, not two of them. So again, pay attention. I do apologize for that. I could graph this either by finding the intercepts, or since it's got an x term and a y term, I could do the slope-intercept thing. But if they want the most convenient, the one most convenient way, it's in standard form. Finding the intercepts and then graphing would be the easiest. Alright, so again, I do apologize for that. So just read the instructions, read carefully. Don't rush through it like I just did. Alright, so again, my bad. Alright, and then finally we have that one with the applications of slope. Alright, so here Janelle is planning to rent a car while on vacation. The equation c equals 0.32 m, so 0.32 would be the slope here, plus 15, that 0, 15 would be the y-intercept, or the c-intercept here. Instead of x we have m, and instead of y we have c. Models the relation between the cost in dollars, c, per day, and the number of miles m she drives in one day. What would be the c-intercept? What does it mean? So basically, if she didn't drive at all, right, if m were 0, no miles at all, c is 15, that's the c-intercept. The c-intercept is, if she didn't drive any miles at all, it would still cost her $15 to rent the car for the day. Right. So c-intercept is 15, and it means if Janelle drove 0 miles, it would still cost her $15 to rent the car. That's the correct interpretation of the c-intercept there. Right, and then the final one of these. So Costa is planning a lunch banquet. So this is like that banquet one from earlier, right? The cost of the banquet is $450 plus $28 per guest, right? $28 times the number of guests. The slope is 28, right? So that's it costs 20, every guest that attends, the cost goes up by 28. But they want the c-intercept. The intercept would be 450. And that is, what's the cost if no guests show up? So if no guests showed up, it would still cost, Costa $450 to like rent the hall or something, or throw the banquet. That's this interpretation here. The c-intercept 450 is the amount in dollars the banquet would cost if there were no guests. Alright, and that should be it for this preview version of this assignment. Again, I do apologize for that one error. Just read the questions more carefully than I just did, right? Yeah. And like I said at the top of the assignment, the questions I saw here are not going to be the same questions that you see necessarily. when you do the assignment on your own. But the objectives are the same, the structure is similar, so I'm hoping that watching me go through these here helps you in some way when you work on the assignment yourself. And thank you very much for watching.